In this video, we're going to go over how many factors there are in 96,000, or how many divisors. Okay, so let's start. 1 works, 2 works, 3 works, 4 works, 5 works, 6 works, and you can keep going. This strategy is pretty terrible because this is a large number, so there are going to be a lot of divisors of that number. So rather than try attacking this problem, we're going to explore a new idea, which is start small and look for a pattern. So let's take a number like 8 and list its divisors. How about 9? Now, this is fine, but let's think about these numbers in terms of prime factorizations. What is 8? It's 2 cubed. 9 is 3 squared. So if you notice, this is 2 to the first, this is 2 to the second, 2 cubed, that's 2 to the 0. This is 3 to the 0, 3 to the first, and that's 3 squared. So what do these numbers have to do with the prime factorizations? Well, if you look at this power of 3, we have everything from 0 through 3. And for 9, we have everything from 0 through 2. So that gives us the idea that we can, if we know the prime factorizations, we can choose any power up to this number and it will be a divisor. So before we attempt this problem, let's take 36. Alright, now 36 is 4 times 9, or 2 squared times 3 squared. And if you notice, what is 1? That's 2 to the 0 times 3 to the 0. This is, so 2 is 2 to the first times 3 to the 0. Let's take 18. That's 2 times 9, or 2 times 3 squared. So I'm jumping around. What are we doing here? The point is, each of these can be generated by picking a power over here that's no greater than 2. So for example, for 6, it would be 2 times 3. So it would be 1 2 and 1 3. If you want to create the entire number, you would just pick the maximum, 2 2s and 2 3s. If you want the smallest divisor, you pick the minimum, 0 2s and 0 3s, and you get 1. So now let's go to the original problem. So 96,000 is 96 times 1,000. Each of these is, this is 10 cubed, 10 times 10 times 10. So there's 3 2s and 3 5s because each 10 has 1 2 and 1 5. 96 is 4 times 24. So that's 2 squared, and this is 3 and 8, and this is 2 cubed. So let's gather all our factors. So 96,000 is 1 2 3 4 5 6 7 8. So it's 2 to the 8th times 1 3 and 5 cubed. All right. So what this means is, if we want to create a factor of 96,000, we can choose any number of 2's as long as it does not exceed 8. So what's the minimum for 2's? We can choose anywhere from 0 to 8. For 3's, it can be 0 to 1, and 5's, it can be 0 to 3. So that's 9 choices, 2 choices, and 4 choices. So if you multiply these 3 numbers, which is 18 times 4, you should get 72 divisors or factors. Now, in general, if you have any prime factorization, you just look at all of your exponents, you add 1, and you multiply them, right? So this is 8, we did 1 more. This is 3 to the first, we did 1 more. 3, we did one more, which was 4. Again, why are we doing this? Because your choices for factors include the prime factorization with exponents from 0 up to the number. So if, let's say your prime factorization is 2 to the 7th, then the smallest power you can pick is 0 to 7. That's 8 choices, so it's always one more than the power. So for any number, you take the prime factorization, add 1 to each of the powers, multiply all the exponents, multiply all those, and that will be your answer. All right.